This is actually it. Hello, I'm Britt Pendleton, and I am a summer graduate INBRE fellow, and I'm really excited to be here to talk to you about my summer research today. This is the father of toxicology, Paracelsus. He once said, "All things are poison, and nothing is without poison. Only the dose makes a thing not a poison." Paracelsus knew what plants knew, that in the right doses anything can be toxic. Plants apply this concept to combat their variety of pests, such as the case of the monarch butterfly, who has become adapted to feed on milkweed, which contains toxic glycosides. To add insult to injury, not only have they adapted to feed on milkweed, they've adapted to sequester these toxins to make themselves unpalatable to their predators. You can see down here on the left, on the bottom, this blue jay is puking after taking a nice bite out of a monarch butterfly. These chemicals haven't gone unnoticed by humans. In fact, we've learned to isolate and synthesize many of these compounds, like in the case of pyrethrins, which were derived from the chrysanthemum family. Pyrethrins have been found to be very effective and non-toxic, but singular use of these compounds has led to rising instances of resistance in many of our pests. Plants have learned to defend against this resistance by using mixtures of compounds in differing concentrations. These mixtures are known as chemical profiles. Another wise note from our good father. The art of healing comes from nature, not from the physician. Therefore, the physician must start from nature with an open mind. Let me help you to open your mind. Welcome to Nature's Pharmacy, where we use wildlife to drive discovery of new drugs by interpreting, testing, and translating what nature has to tell us. Idaho hoden, golden eagles, and other birds have been observed incorporating aromatic greenery into their nests. It is hypothesized that they are exploiting doses of chemical sources within their habitats to combat pests found in their nests. Meet one of those pests. A quick little bloodsucker that goes by the name of Mexican chicken bug. The chicken bug, like its cousin the bedbug and other bloodsuckers, is vulnerable to plant toxins. This is because bloodsuckers are highly sensitive to chemical changes in their environment. How do we know, though, the golden eagles are doing this? From observing golden eagle visits, we saw this eagle fly into Walmart and take off the shelf. No, I'm just joking. Actually, what we did was we cataloged green nest material from golden eagle nests and then compared that to availability within the nesting territory. We found the golden eagles enjoyed a diversity of plants as green nest material, but there was a preference for the inclusion of rabbit brush. We also identified spiny hopsage as being a preferred plant. And we decided to also include sagebrush in our bioactivity tests, mainly because we have a lot of knowledge about the chemical profile of sagebrush, and sagebrush is highly available in the nesting territories. So we collected plant material from the nesting territories and brought them back to the lab, where some nest material was extracted to create a low chemical profile, seen here in pink. The rest of the plant material was left intact and kept frozen to create our high chemical profile, seen in green and red here. Test subjects then received a low chemical profile and a high chemical profile of an assigned plant of interest. I monitored and recorded behaviors of a test subject over a period of 2 days under both conditions. this is what the data wound up looking like. There were 3 ways a bedbug would spend their time. They would spend their time resting, exploring, or grooming. I then compared how subjects divided their time under these different chemical profiles. And what I found was that bedbugs were less likely to rest in the presence of plant chemicals, and more likely to spend time exploring and grooming. We interpreted this as chemical agitation. Chemical agitation most likely targets the olfactory regions of insects. In chickenbugs and bedbugs, this area is concentrated on the tips of their antennae. These regions are highly sensitive to terpenes and other volatile chemicals. Terpene compounds have been found to be effective in insect repellents. Our recent gas chromatography analysis helped us identify known and unknown terpenes of interest within our plants of interest. And we now have gas chromatography mass spectrometry to couple with this GC data to help us identify unknown terpenes and their concentrations. We have also started the process of identifying phenolic compounds within our plants of interests. We have made concentrated extracts over at the College of Idaho that we performed high-pressure liquid chromatography on. We then brought these same extracts over to the BRC mass spec facility to perform liquid chromatography mass spectrometry. These techniques will help us quantify phenolic chemical profiles in our plants of interest. Phenolics are just another class of defensive compounds. And analyzing both terpenes and phenolics will give us a better idea of the full defensive chemical profile within our plants of interest. So far, in our journey to use nature's pharmacy, we have interpreted plant preferences of golden eagles, we have tested for bioactivity of plants against a blood-sucking pest, and we are now in the process of analyzing chemical profiles for 2 defensive chemical classes within our plants of interest. And not a moment too soon. We need this knowledge now. As resistance is growing and showing no signs of stopping, some of our most effective pesticides are under attack by resistance, with consequences that affect the world every day. We need answers to fight resistance now. And on that light note, I'd like to thank my funders, found here on the right, and my other funders, I guess, over here on the other side, but they also gave me other things that I needed. Oh, that's not great. I'm going to find a better way to say that. I promise I won't disappoint you tomorrow. Okay. Thank you for listening. Bye.